Okay, geometry. Thursday the 10th, SWBA students will be able to solve equations for a specific variable. Solve equations for a specific variable, section 1.6. All right, so some equations have more than one variable. We'll see this a lot in geometry, especially with formulas, okay? You might also see this in science class with formulas. So sometimes it can be helpful to isolate one of the variables. Now we're going to solve these equations very similarly to how we would solve them in we would solve a normal equation in algebra. For example, number 1, 15 equals 2n plus 6p. 15 equals 2n plus 6p. There's two different variables here. What variables do we see? N and p. Awesome. Now what one are we supposed to solve for? And that means we're supposed to get n by itself. Now what would you do first if I covered up this p and this didn't exist? How would you solve for n? Subtract 6. So because we have p there, we're going to subtract 6p. We're still going to do the same idea. Subtract 6p. Kenny?
Did you have this short lesson because you knew we were going to take a long time in the homework today?
Pretty convenient.
Okay.
I know.
Okay, we'll subtract 6p from both sides. Now, can we do 15 minus 6p? Are those like terms? No, but here's what we can do. I can write it out. I can just write it. 15 minus 6p. I can just write 15 minus 6p equals 2n. So I can write 15 minus 6p equals 2n. Okay? Lauren, let's actually have you sit right there for the day. That might be a little better. Okay? 15 minus 6p equals 2n. Is n by itself yet?
No.
What do we have to do? Divide by 2. Now I have to divide the entire left side by 2. I can't just pick and choose one thing to divide by 2. I have to divide the entire thing by 2. Now, does 2 go evenly into 15? No, it does into 6 though, but not into 15, does it? And we have to divide both of them. But what I'm going to actually let us do is, because it doesn't go evenly into everything, I'm going to let us just rewrite that. 15 minus 6p over 2. And that's just equal to n. Is n by itself?
I put n equals 3p.
Hey, n is by itself? Dope, we're done. Okay, what did you put, Seth?
N equals 3p plus 7.5.
It would have to be negative 3p, and then I would count that okay. Okay?
Negative 3p.
Questions on this one?
Negative 3p.
No. Does this look a little bit weird? Yeah. But we did all the right math still. We just can't combine like terms. If we knew what p was, we could plug it in and simplify it even more to actually get an actual number. But right now, this is the most we can do without knowing what p is. We solve this, I don't know. We solve this the same way, though. We solve this the same way we would normally, except for now we just had a p attached. Number 2, k minus 2 over 5 equals 11j. K minus 2 over 5 equals 11j for k. So we have two different variables here. We have k and we have j. We have k and we have j here. What variable are we asking to solve for? K. What would be our first step to solve for k? Multiply by 5, because it's being divided. Okay, we would love to get rid of the addition subtraction first, but we can't because it's part of the fraction. So first we actually have to multiply by 5 on both sides. Sometimes it can be helpful for us to think of this as a 5 over 1, right? Okay, these 5s will do what? No, I don't like that word. They reduce out, they simplify out, bless you, unless it rains on it after us. Forget. They both become 1. So we're left with k minus 2. Don't make fun of my k's. Everyone makes fun of my k's. It's a k, okay? Get over it. K is equal to, what's 11j times 5? 55j. Okay. How else do I have to get the k by itself? What else do I have to do? Add 2, right, Elizabeth? Elizabeth, can I combine 2 and 55j? Thanks, Elizabeth. Okay. But I can write 55j plus 2, can't I? Is k by itself? We're done. In some ways, this is actually less work. In some ways, this is actually a little bit less work, isn't it? Because we don't actually have to, add them together. We just have to write it. Questions on that one? Next one. 2w minus y equals 7w minus 2. How many w's do we see here now? 2. What are we solving for? W. What's our first step when we have two of the same variables? Get them together. Elizabeth, how are we going to get them together? Let's subtract the 2w from each side. Let's move the smaller one to the bigger one to keep them positive. 2w minus itself is 0. Negative y. Don't forget this is a negative y. That negative stays there with the y. Equals 5w minus 2. How else do I have to get w by itself? Okay, Tyler.
Divide by 5.
Before I do that, I have to do something else. Elizabeth, what do I have to do before that?
You have to add 2.
I have to add 2. We want to deal with addition subtraction first when we can. 2 minus y or negative y plus 2 either way is equal to 5w. Now, Tyler, what can I do?
Divide by 5.
Divide by 5 on the whole thing. Does 5 go evenly into 2 or 1? Nope, we're going to leave it as is then, and we're going to call this one 2 minus y over 5 equals w. W is by itself. We're done.
We need a baking crusade.
Yes. Questions on that one?
We're gonna go.
We need to do the baking.
Questions on that one?
No.
Okay.
I'd like to make the baking.
Yes, well, let's do the baking crusade.
That's a W, right?
All right, number 4. This is a w.
Yes, ma'am.
Number 4. 3/4 a. 3/4 a minus x is equal to k. 3/4 a minus x is equal to k. 3 variables now. We're not going to panic. We're going to do the same idea. We're solving this one for a. A is being multiplied by 3/4, subtracted by x. What do we take care of first?
The 3/4.
Nope. Elizabeth?
Add x.
Add x to both sides. We want to deal with addition, subtraction before we do the multiplication. The only exception was number 2 because the whole thing is being divided. At negative x plus x is 0. We're left with 3/4 a is equal to k plus x. Could we also put x plus k?
Yeah.
Sure, you can add in any order. Thank you, Tony. Okay, how do I get rid of that 3/4 in front of the a? Elizabeth?
Divide 3/4.
Okay, divide by 3/4. And when you divide by a fraction, you really multiply by its reciprocal. So we're going to multiply by 4 over 3, the reciprocal on both sides.
You're writing
Arms are weird K's.
Okay? What's going to happen with this 4 and this 4? Look up at the board. This 4 and this 4. What's going to happen?
cancel out.
Not cancel, but they're going to reduce or simplify. I'm a meanie with that one, okay? What's going to happen with these 3's? Okay, cross reduce. Very good. We're left with A. Now, here's the thing.
Hey, you have to leave.
With a fraction, I'm going to be chill with you guys leaving it like that. With a fraction, I'm going to be chill with you guys leaving it as A equals 4/3 times the quantity of k plus x.
What if you did?
What if you distributed it?
No, what if you did just k plus x and then 4/3?
Oh, you put the 4/3 on the back? That's fine.
Okay.
Great question. Any other questions on that one? Alrighty, continuing on. Kenny, please don't play with the protractor.
Yes, sir.
Using formulas. We're going to do this a lot in geometry, especially later. Sometimes solving a formula for a specific variable will help us solve the problem. Okay? A car's fuel economy. We're going to call it capital E. A car's fuel economy, capital E, in miles per gallon is given by the formula E is equal to M over G, where M is the number of miles driven and G is the number of gallons of fuel used. That's actually how you find mileage. Like every time I go and fill up gas, I find my mileage. I take however many miles I drove, divide by the number of gallons I got, and I say, oh, I got 30 miles to the gallon. That's awesome. What?
Everything in your life is math, is it not?
Yes.
Like you just sleep math.
Yes.
Like you dream about math.
Yes. You don't?
You're annoying people around.
Okay? No, like seriously, I'll find my mileage every time I fill up so I know if something's bad with my car or what kind of mileage I'm getting. What?
How old is your car?
It's an 07.
Doesn't it show you mileage?
No, that one it's like a super base model. It doesn't even have a tripometer. I have to keep track of it with pictures on my phone to say, oh, I was this mileage last time, this mileage this time. It's kind of sketch. That's okay. So we're supposed to solve this formula for M. E equals M over G. We're supposed to solve for M. What's happening to M right now, Ray?
Oh, that's my passing.
That's awkward. Go get it. Okay. Let's go and say what's happening with M right now. It's being what? Divided. How do we undo division? Multiply by?
Anti-division?
Okay. Hold up. Okay. Multiply by what? G, because we're dividing by G. So we're going to multiply both sides by G. Sometimes it's helpful for us to think of this as G over 1. What's going to happen with the G's on the right-hand side? Cross reduce. Tony, you're nailing that. G times E. Do we know what G times E is? No, but can we write it? You betcha. G times E is equal to M. Is M by itself? Yes, we have our answer. We solved the formula for M. Here's where it's going to come in handy in part B. Part B comes in handy. If Claudia's car has an average fuel consumption of 30 miles per gallon, and she used 9.5 gallons, how far did she drive? Okay, fuel consumption of 30 miles per gallon. Is that E, M, or G? E as in elephant. It is a fuel economy in miles per gallon. Okay, so we have 30 miles per gallon is our E. She used 9.5 gallons. Is that M or G? G, gallons. And we're asked to find how far did she drive. How far? Is that M or G then? Or E? M. Can we take these three and plug them into the equation? Yes. Now we're going to be solving for M, right? Because that's one we don't know. So would we be better off using our original equation or this one we already solved for M?
The one we already did.
One we already solved for M. We're going to save ourselves some work.
Yes, let's go.
So instead of G times E, it's going to be 9.5 for G and 30 for E. And that's going to be equal to our M. So now we take 9.5 times 30. We plug what we know into our formula and solve for what we don't. We plug in what we know and solve for what we don't. We know E is 30. We know G is 9.5. We don't know M. Plug in what we know, solve for what we don't. 9.5 times 30 is going to be, does anyone know? 285. We are allowed calculators in here, so 285 equals M. So how far did she drive 285 what? Ostriches? Miles. She drove 285 miles on 9.5 gallons. That's pretty good mileage.
I saw a meme about that last night. Maybe laugh.
Okay? Questions on that? Oh, nice.
I think it's banana.
Formula for volume of a cylinder. That's something we're going to do in here second semester. Volume of a cylinder is V equals pi r squared h, where r is the radius of the cylinder and h is the height. So we have this equation, V equals pi r squared h. And we're asked to solve the formula for what? H. What's happening with h? That's our question. What's happening with the variable? Tyler. Multiplying with what? Pi and r squared. How do we undo multiplication? Divide. So what are we going to divide by? Pi r squared. You're going to divide by whatever you're multiplying by.
So, how do you square pi?
You don't square pi, you square r. So we're only squaring r there because the square is only on the r. If the square is on the pi too, if it was like this, then we have to square pi, but we don't.
You know what it is.
Okay? We don't know what it is. We're just writing it right now. Do we know what v divided by pi r squared is?
No.
Can I write v divided by pi r squared though?
No.
So if we know what they were, could we plug them in?
Yeah.
Totally. That's going to equal, well, pi divided by pi, those simplify. R squared divided by r squared simplify. Left with h. Is h by itself?
Yeah.
Ooh, we did it. Okay. Part B is where this comes in handy again. What if the height is what letter? H, of a cylindrical swimming pool, we were doing with a cylinder, has a radius, what letter is radius? R, of 12 feet, and a volume, what letter is volume? V, of 1810 cubic feet. So we're asked to find what letter? H. Did we already conveniently solve for that letter in letter A? Yeah, can we plug it into this equation now? So what goes on top?
1800.
Yep, because that's our V.
1810, baby.
Pi times what squared? 12 for R. That's going to equal our H. Questions on why we plugged it in where? Any of that?
How would you just divide by the reciprocal?
Great question what we do. We're actually going to work on squaring first. We're going to go through our normal order of operations. So what is 12 squared? 144. We can call it 144 pi or pi times 144. Typically, we write the number before the pi. Now, pi is a number. Okay? Pi is a number. Pi is approximately 3.14. Can somebody take a calculator right now? Somebody take a calculator right now. Okay? Tony, can you do 144 times 3.14? 144 times 3.14.
You said 144?
Yep, times 3.14. We're taking 144 times pi, or approximately pi.
452.6.
I got 452.6.
Okay, you both got it? Perfect. So 1,810 over 452.6 is approximately our height. Notice we rounded, didn't we? Because I'm sure you guys got, because we rounded to get 3.14 for pi. Otherwise, pi is 3.14159, blah, 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 blah. Keeps going forever.
Wait.
What did you do before the H?
Yeah, it was 0.16.
What did I do before the H?
That's like not an equal sign.
Yeah, it's not an equal sign. Because it's approximately. Anytime you do approximately, it's like this.
Hey,
I just got
our answer's wrong. It's .52 or 452.16.
No, it'd be 452.
No. I got-
3.14 times 144 would be it'd be 400 something.
I got 452.16.
Oh, 0.16.
Yeah.
2.2.
I got
Okay.
452.3.
We'll call it 452.2. Now let's take 1,810 divided by 452.2. Let's take 1,810 and divide it by 452.2, and we'll find out what our height is approximately.
Is that X?
Where?
It's the rough equals.
Yeah, it's our approximate.
I thought it was like a messed up X.
What? It's approximately 4. So our height is approximately 4 feet.
It's an X of monkey battle.
So the height of the swimming pool is about 4 feet.
Wow, that's a short pool.
That's
It's like shorter than the pool I got.
Okay, questions on that one.
no.
So is our math really much different than what we did before? No. We're just applying it in a different way.
Yay.
Questions on that? Okay, 1 second. On the front, I want you to do the odds. But on the back, I want you to do all of them.
Okay, Mr. Cross.
That makes sense? On the front, I want you to do the odds. On the back, I want you to do the all of them.
How do you want me to clean this? Like, do you want to clean it